JEE Main 2026, 4th April Shift 1, Physics Section A, Question 45. Let us visualize the setup. Unpolarized light travels from air and strikes the surface of a dielectric medium at Brewster's angle. The coordinate system has x hat pointing upward perpendicular to the surface, y hat along the surface to the right, and z hat going down into the medium. At Brewster's angle, the reflected and refracted rays are perpendicular to each other, that is, they make a 90-degree angle. Crucially, the reflected beam is completely S-polarized, meaning its electric field oscillates perpendicular to the plane of incidence. The question states, an unpolarized light is incident on the plane interface of an air dielectric medium. If the incident angle is equal to Brewster angle, identify the expression representing the reflected wave. The four options are shown, each with different electric field components and wave propagation terms. The key concept here is Brewster's law. Brewster's angle is defined by tan theta b equals n2 over n1. At this special angle, the reflected and refracted rays are perpendicular, meaning theta r plus theta t equals 90 degrees. The most important property, the reflected light is completely S-polarized. This means its electric field oscillates only perpendicular to the plane of incidence. The P-polarization component, which lies in the plane of incidence, is entirely transmitted and absent from the reflected beam. Step 1. Determine the polarization direction. The plane of incidence contains the normal, which is the x-axis, and the propagation direction of the rays. Since the light comes from the left and hits the surface, the plane of incidence is the xz plane. At Brewster's angle, only S-polarization survives in the reflected beam. The S-polarized electric field is perpendicular to the plane of incidence. So the reflected E field has components in the x hat and y hat directions, since these are perpendicular to the propagation direction. Step 2. Determine the propagation direction. The reflected wave travels upward, away from the surface. Looking at the phase term in the wave expression, kx minus kz minus omega t. This means the wave vector k has a positive x component, meaning the wave travels upward along the normal direction, and a negative z component, meaning it travels away from the medium. This is exactly what we expect for a reflected ray bouncing off the surface and going back into the air. Step 3. Let us eliminate the wrong options. Option 4 has 3 electric field components, meaning it is not linearly polarized. At Brewster's angle, reflected light must be linearly polarized, so option 4 is eliminated. Option 3 has E in the J and K directions, and the propagation is along Y and Z. The reflected ray should go upward, not sideways, so this is wrong. Option 2 has E with a Z component. Since Z is in the plane of incidence, this represents P-polarization, which should be absent in the reflected beam. Eliminated. Option 1 has E in the X and Y directions, with propagation described by Kx minus Kz. The E field is perpendicular to the propagation direction, and the wave travels upward and away from the medium. This is correct. The correct answer is option 1. The reflected wave at Brewster's angle has its electric field with components Exi hat plus Eyj hat, and the wave propagates with phase Kx minus Kz minus omega t. This perfectly describes a S-polarized wave reflecting upward and away from the dielectric surface. Here are some exam tips for Brewster's angle problems. Memorize these key formulae. Tan of Brewster angle equals n2 over n1. The reflected and refracted rays are perpendicular at this angle. And most importantly, the reflected beam is purely S-polarized. Tip 1. Use the 90-degree relationship between reflected and refracted rays to quickly determine angles. Tip 2. For wave expression problems, always verify that the electric field vector E is perpendicular to the wave vector K. Their dot product must be 0 for a valid electromagnetic wave. Like and subscribe for more JEE Main solutions at MAGPIEHUB.